with sequences and series. Today, though, what the twist is, we're going to be looking at a new type of sequence and series called geometric sequences. So remember Monday and Tuesday, what we did were arithmetic sequences and series. What's different about today, sorry, I'm having a pen malfunction here. Let me try it again. There we go. Today, it's geometric. And what does that mean? Geometric sequences, a list of numbers, just like before, whose pattern from one term to the next is a common ratio. Common ratio, not a common difference. That's what we saw for the last 2 days was a common difference. Here, it's a common ratio. What does this mean? The ratio means not a number that we're adding and subtracting to get to the next term in the list, but a number that we multiply or we divide. So that's the difference between our geometric sequences and then our arithmetic sequences like we saw yesterday and on Monday. Morning, Philman. Morning. So let's start with an example. Here's our first sequence for today. 4, 8, 16, 32, 64. If we were to try approaching this sequence like we did on Monday and on Tuesday yesterday, we look for the space between each number. So for example, there we go. For example, from 4 to 8, if we were adding, that's plus 4. But then when I go from 8 to 16, that's plus 8. And 16 to 32, that's plus 16. See the problem? It's not the same pattern or same number that we're adding each time. So that's our clue that it's not an arithmetic sequence. That's our clue that this is a geometric sequence with a common ratio. So we're not looking for a number we're adding or subtracting. We're looking for a number that we are multiplying or dividing each time. So let's try it that way. Is there a number I can multiply to 4 that gets me to 8?
Hi, Josiah. I wanted to say sorry for being late. I was having some internet connection issues.
It's all good, Levi. Thanks for joining. You're not too late. I appreciate you being here and telling me.
Yeah.
Anaya says times 2. Awesome, Anaya. I think you're right. Let's double check with all of the ones they gave us. So 4 times 2 gives us 8. 8 times 2. Remember, for it to be a rule, it has to work for every single number in the sequence. And so far, this is working. 8 times 2 is 16. 16 times 2 is 32. And double check the last one, either by hand or in your calculator. 32 times 2, does that give me 64? It does. Levi and all of you, we haven't gotten very far yet today. This is all we've done so far. We've defined geometric sequence. And just think back, the last 2 days we've been doing arithmetic sequences. And I told you then, we're going to see another type later. Well, this is the other type. Instead of a common number we're adding to get up or down to the next term, it's a common ratio. R for ratio. So that's going to pop up in the formula later. And the common ratio is a number that we're multiplying or dividing. So in this example, 4, 8, 16, 32, 64, we tried doing it by adding, but we don't get the same common difference. So that's our clue that we're multiplying something instead. Times 2, times 2, times 2. If you don't see the pattern on your own in your mind, like you might have seen this time, 4 times 2 is 8, 8 times 2 is 16. Here's how we can find that common ratio. This will work for every problem. How to find common ratio? Not ration, ratio. You're going to divide any of the terms by the one before it. So how to find the common ratio? This will work every time. Divide any term that's a number from the list by the previous term, the one before it. So for example, if I picked 32, I divide that by the one that came before it, 16. Do it in your calculator, you get 2. That's R. Try it again. Start with 16, divide 16 by the one before it, and it gives me 2. Same R. So this approach will always work, okay? If you don't see it automatically, it's like sometimes they're kind of easier, ×2 or ×3. Maybe you see that right away. Maybe we get a weird fraction for our common ratio. So to find that weird fraction, to find the common ratio, this will always work. Divide any term by the previous term, the one that came before it. I'm going to hold on to this page for a few moments. If people are writing down or getting our screenshot taken, I want you to have this for later in your notes. We'll do a couple examples of this, and then we're going to look at the geometric series. And remember, series means we're adding up all the terms up to some certain point. So there's a formula for that as well as for sequence for this. Okay, and if there's any questions or concerns right now, please let me know. How are we feeling so far on this?
I don't have any questions.
Thanks, Levi.
And it seems pretty simple.
It's good so far? Okay, good to hear. I'm glad you're doing okay so far. Good. I hope everyone else is doing okay as well. Let's try another example. And we'll talk about the formula and then the notation, just like we did for arithmetic on Monday. Here's a different example, different sequence. 3, 9, 27, 81, 243. See how big this climbs? Like, it's much faster than the arithmetic sequence. All of a sudden, we're at 243 for the fifth number. I want you guys to try finding the ratio, the common ratio, R. Can you see what we're multiplying by to go from one term to the next?
I think we're multiplying by 3.
Tira, thank you. I think you're right. Let's double check. Once you see it for one section, make sure it works for the whole thing, just to be sure. 3 times 3 is 9. Good. 9 times 3, 27. Yes. I'm going to check these next ones in the calculators. 27 times 3. I got 81. So it's looking good. That means R is our common ratio. 3 is our common ratio this time. Remember, that means the common ratio, just like the common difference, except it's something we're multiplying, not adding or subtracting. I keep writing ration. What is going on today? I need help. Okay, common ratio. There we go. And in the chat, times 3. Savannah? Yes, thank you. So let's look at the notation. Some of this is the same as it was for our sequences, arithmetic sequences earlier. So we still call the terms A numbers. So 3 is A1, A sub 1. 9, that's the second number, that's A sub 2, and so forth. So we're going to be using that same language for geometric sequences. Hey, Xavier. I'm glad you made it.
Hey, how are you?
Good. Xavier, we did start the first page of this already. Today we're starting geometric sequences. Um,
Okay.
so it's similar to what we did on Monday, but instead of a common difference that we're adding to get to the next number, now we're doing some number that we're multiplying or dividing.
Oh, okay.
Similar to Monday, but there's a little twist. It's that we're multiplying or dividing instead of adding or
All right.
subtracting. Okay,
Thank you.
thank you. And of course, if we're looking for some number later on down the list, like the nth number, I'm going to add that to my list above, then we would call that number a sub n. So the nth number in the list. Okay, let's look at the formula for this. Geometric sequence formula. So just like the arithmetic has its formula to find a sub n, we have one for the geometric. A sub n, the nth number in the list, or nth term in the list, is the first term, that's a1, times the common ratio, r, to the n minus 1 power. Now think back to how we were using exponents last fall together. So this is not r times n minus 1. This is the n minus 1 power, an exponent. This is an exponent, this whole n minus 1. I'll put it in parentheses there to group it together, okay? So it's just like we saw for the arithmetic sequence on Monday, that n minus 1 we kept using. It shows up here as well. Let's see. I want to test it out like we did on Monday. Oh, here's a note I had for us. To write the formula, all we need is the first term and the common ratio. So if we're asked to write the formula, all we need to know for sure is what is A1, the first term, and what is R, the common ratio. And then we're going to plug them into this formula, the blank generic version of it, and then there we go. We could find any number in the list. Let's practice it with the sequence we have above, just to see how it works and that it makes sense, or that it works at least. So let's see. I'm going to change to red to distinguish from what I'm doing. So let's test it out to see the fifth term. The fifth term in the list, we already know it, is 243. But let's check the formula to see if it works and how it operates. So in my red box here, I want to find a sub 5. The first term, a1, is 3. Cool. And that's times r, which is actually also 3. We found r, the common ratio. The rule is times 3, so that is my r number as well. Okay, it's not always going to be the case that a1 and r are the same. I just did that for this example. Maybe I shouldn't have. And then that's to the n minus 1 power. Now, what do we plug in for n? Well, I want to find the fifth number, a5, so we're plugging in 5 for n here. So let's do that. 3 times 3 to the 5 minus 1 power. Okay, so just like we did in our formulas Monday and yesterday, we're going to simplify the n minus 1 first, and then we do the exponent. So 5 minus 1 in the exponent, that's 4. So it's 3 times 3 to the 4th power. So we can do this in 2 steps. We can do right here, I'm going to underline it. We can do 3 to the 4th power. Try it either by hand on paper or in your calculator. How do we do a power again? Do we remember how to do that? How do we do an exponent? Can anyone share with me in your own words how you think about exponents and how we simplify or solve it? 3 to the 4th power?
We would do 3 times 3 times 3 times 3.
Exactly. Thank you. 4 times. Good job. So this 3 to the 4th power is, if you wanted to expand it, there we go. I'm going to underline it. There's my 3 to the 4th power. So really, because it turns out A1 was also 3, we have 5 of these all together. So multiply those guys out. Do we get what we wanted to get? We were hoping this would be 243. Because we already know the answer. We knew the 5th term up here in the list was 243. So we're just checking our formula to see if it works. 5th term. So we can use this formula to find any number. If they ask you for the 20th number in the list or the 100th number in the list, as long as we have our formula and we know the first term and we know R, we can plug them in. We have to simplify it, and then it'll give us that number in the list. Get that out of the way. Okay, before we move on, any questions or concerns right now?
I don't have any.
Okay, thank you. It's okay if you do. You can always type your questions or concerns in the chat. I'm checking that too. All right, let's move on then. Let's do another example. I set it up just like we did our work on here. I'm going to move that up top. Just like we did our work on Monday and Tuesday. Use the given sequence to find the common ratio, write the formula, and then find a sub 10 in a step-by-step way. So find R first. What is our R this time? What is our formula? And then what is a sub 10? Cool. I see someone in the chat responded. Does anyone else want to respond with what R is? Can you find what R is? What is the common ratio? What is the rule they're using? To multiply, to move up the ladder, so to speak, and get the next number.
Can I say it out loud?
You can, but hold on, not yet. I want to give people a chance to respond in the chat.
Okay.
4 messages in the chat. Let me check on you guys. Awesome. Savannah, Tatiana, Anaya, and Tira, you wanted to say it out loud? Go for it. What do you got?
I got 2.
Yeah, times 2. 5 times 2 is 10. Good. 10 times 2 is 20. Still working. 20 times 2 is 40. Oh, wait a minute. My bad. This is a typo. Sorry, Josiah's. This is supposed to be. What should this be? Should not be 40, huh? What should this number be if we're doing times 2?
60. 80.
80.
Oh, 80. Yeah.
Okay, my bad, everybody. Good eye. Thank you for helping me. 80. Okay, so let's use that. So there's our sequence. We have our R. R is 2. Woohoo! We need the first number in the list, A1. That's 5. So to write our formula, it's A sub n is equal to A1. I'm going to put it blank again first, times R to the n minus 1. So let's fill those parts in down below. So A sub n is A1, 5, times R, that's 2 this time, to the n minus 1 power. There's our formula. And now we should be able to use that to find any number in the list. Let's find A sub 10, the 10th number in the list. A10 is 5 times 2 to the 10 minus 1 power. So do the subtraction first, then you're going to do 2 to that power, and then you do times 5 at the very end. So 10 minus 1, that's 9. So we're going to do 2 to the 9th power. Now, what Tira said is completely legitimate. We can do 2 times itself 9 times. When the numbers get really big, though, when we're doing 9 in a row, that's an awful lot. And I might make a mistake doing 2 times 2 times 2 times 2. So I want you guys to practice using the actual exponent buttons in your calculators. Whether you're on your phone or you're on one of these, you should have a button there that you can use for exponents. On our phones, I think it looks like this. Look in the top right. Usually it's like X to the Y. I'm pretty sure that's what I've seen on most phones. Or maybe it's A to the B. Okay, if it looks different, I want to help you find that button, that key to use in your calculator. So what I'm going to do is do 2 to the 9th right away, just in one move on my calculator. So enter 2, and then my exponent button, like those two on the top right, yours might look like that, and then 9. So I got 512 just for 2 to the 9th. Double check me. If you got something different, let me know. I want to work on it together. And then we have to still do times 5. So 512 times 5, 2,560. Holy cow. So that means the 10th number should be 2,560. Let's see. Awesome. Savannah, thank you for checking with me. If you didn't get that, try it again and see if you can find what the what's going on. Savannah and I got the same thing, but check your work and tell me if you can get that number, 2,560. Or if you can't, I want to help you kind of figure out how to use the button on your calculator. You know what, guys? Another option, if you're on a computer for this call, Tatiana, thank you, and Tira. If you're on the computer, you can use the Google calculator pretty easily. Let me just show you that real quick. So in Google, just type in calculator. And boom, you get this. On here, what's our exponent button? It's this one, x to the y power. So how do I want to type it in here? We did 2 to the 9th, right? So 2, and then hit this button to x to the y, and then 9. Look, and it set it up like an exponent, and then hit enter. 512. And then we have to do that times 5 at the end. So Google Calculator is an option if you're on your phone. Maybe that'll be easier. It's up to you. Back to this. Good job, guys. Thank you for the help. Let's try another one. This time, same questions basically. Find the common ratio, write the formula. And this time I want to find a sub 9, the 9th number in the list. Excuse me. This time, though, it might be a little tricky finding r. The numbers are not getting bigger. So if that means if our numbers are getting smaller each time, that means we're dividing by something, not multiplying. But it's still a geometric sequence if we're multiplying or dividing. So what are we dividing by this time to get us the next number in the list? Divided by 4. Nice. Anaya, good. And Savannah, you're both correct. So one person said it's 0.25. You're right. So technically, that is multiplying by the decimal 0.25 each time. That works. Or you can think of it as dividing by 4. It's the same thing. Because let me show you on the right side. If I divide by 4, 1 over 4, anything divided by 4, well, that's the same thing as, when you put that in your calculator, 0.25. So you could think of it as like multiplying by the fraction 1 over 4. You could think of it as by multiplying by the decimal 0.25, or you could think of it as just straight up dividing
Josiah, I had a question.
by 4. Yeah, go ahead.
So starting from 4, can't we do it backwards, and that's how we can guess we're dividing by 4 also?
Yeah, absolutely. Absolutely.
Or we multiply backwards.
Multiplying it backwards. Yeah, exactly. I see what you're saying. So you're looking at 4 times 4 gets me 16, right?
Yeah.
So that must mean we're dividing by 4 to go this way.
Exactly.
Exactly. Good, Tira. Good observation. And I and Savannah, thank you all for participating. So we found 4. Now just be careful though, because I think most of us, and me included, have a tendency to want to work with multiplying over dividing, right? So my common ratio is dividing by 4. So let's write it how Anaya said it, as either the decimal 0.25 or the fraction 1 over 4. Because that's what we're multiplying by each time. So if we find it as a division, make sure that you either put that under 1, like 1 over 4, or write it as a decimal. That's legit as well. Okay, formula. A sub n is the first term times the common ratio, 1 over 4, to the n minus 1 power. Now we've got to find a sub 9, ninth number in the list. So a sub 9 is 1024 times the fraction 1/4, and then that is raised to the 9 minus 1 power, the 8th power. Okay, now we just got some practice together in Unit 5 doing exponent stuff. So there's lots of different ways that we can think about fractions with exponents. There's lots of different ways if we use all those different rules that came up during Unit 5. I want to show you quickly here both ways to do this as a decimal, if we use it 0.25 instead, or as the fraction 1/4. In the chat, do you have to put 1/4? No, good question. And that's exactly what I was trying to get at. We can do 0.25. So here in yellow, I'm going to show next to it an alternative way to do this, okay? We can alternatively write this as 1024 times the decimal 0.25 raised to the 8th power. Because, why is that okay? Because 1 over 4, that fraction, is 0.25. It's just two different forms of the same value, the same thing, two different ways to write it. And honestly, I think the decimal might be easier to work with in this case. If you type in your calculator now, 0.25, exponent 8, we get a big funky decimal. I got 0.000015259. That's a nightmare to write down, I realize. But if you keep it in your calculator and we just hit times 1024, we get this answer. Okay, now that's still kind of scary looking. If we try this in red on the left side with the fraction version, we're going to get a fraction answer instead of a decimal answer. So let's compare those two real quick. Oops. And the truth is, guys, I'll bet you Edmentum is going to veer more towards the fractions. So let's try it in red now with the fraction. 1 over 4 to the 8th power. And I'm sorry, I've kind of run out of room here. So just continuing in red, 1024 times 1/4 to the 8th. the whole fraction, 1 over 4, is being raised to the 8th power. So this is essentially 1 to the 8th, which is still 1, over 4 to the 8th below. Uh-oh, I'm losing people. Okay, so I'm moving to the left to finish this work. Now, let's do 4 to the 8th power and keep it in a fraction form for now, just to see what this answer looks like, not as a decimal. So 4 to the 8th power is a huge one, 65536. So it's 1 over 65536. Okay, yikes. So this, and then if I multiply the 1024 times my fraction, remember those are just multiplying top to top or number to the top. So our answer technically is 1024 over 65,536. And real quick, let's try that division in your calculators. This fraction we have, as scary as it looks, should come out to the same decimal we already got in yellow. So 1024 divided by 65,536. Yeah, it comes out to the same thing. So the decimal is correct. It's a legitimate answer. In the real world, this is something you could measure. Even though it's a really small number, we can measure that on like a ruler. We can't really measure fractions. You have to turn them into decimals. I think we should also reduce this fraction a little bit. So let's see if we can do this fast. 1024 divided by half and 65,536 divided by half. Yikes. 32,768. And then 1024 is going to be 512. Try it again. Divided by half. We're just reducing the fraction. 32,768 divided by half. 16,384. Okay. And you know what? We could keep going. And I guess we should. Sorry about that. I didn't realize I gave such a big numbered answer to reduce until now. So let's try cutting it by fourth. Let's try dividing 16,384 by 256 and cut right to the chase. 16,384 divided by 256. Cool. So this whole thing is coming out to 1/64. Okay. And double check, does 1 over 64 still give us that yellow decimal? 1 over 64? Yes, it does. All right, we should probably do more practice with these just in case. I didn't mean to make this one so complicated for your first division one. What am I dividing by? Good question. So I was dividing by 2 to start with. I'll put that in. I divided by 2, and then I divided by 2 again, top and bottom. But then at the end, Anaya, because I saw that it kept coming out even, I just tried to divide both top and bottom here by 256. And it worked. I didn't know it was going to work. But we got lucky. And so since it worked, that means we could cut right to the end. So that means we could have started at the beginning and just said, divide top and bottom by 1024, and we would have got our final answer. Okay, now not all the problems we do in geometric series or sequences will be this much extra work at the end, but it is good to be prepared for it. Okay, let's move on. Oh, darn it, it's already 11:40. Let's move on. In fact, I'm going to skip this example. Let's try this one. Okay. This time, it's still a sequence problem, but they're not telling us straight up at the beginning what the sequence looks like. what is the nth term of the geometric sequence that has a common ratio of 5? That's good. They just told us r, and 30 as its third term. So that means A3 is 30. Okay. Now they're asking a different kind of question, and they're giving us kind of different information than normal. Normally, we would want to have the first term. They're not telling us that. What is the nth term? They're asking us what is the formula essentially. What is a sub n, the nth term? So here's what we need. We need a sub 1 and we need r. They gave us r, so that's good. So we need to find a sub 1, the first term, and they're telling us the third term in the list. So let's see if we can figure this out. I'm going to make the sequence with some blanks here, like we are used to. I'll put 5 down. And they told us the third term is 30. So if the common ratio is 5, that means multiply by 5, multiply by 5. And now we're going to do, I'm going to fill some of those out. So 30 times 5 is 150. And then 150 times 5, oops, is 750. But now we're going to do what Tira noted earlier, and we're going to go backwards. So if I divide by 5, it'll go backwards in the list, and eventually we'll get the first term. So 30 divided by 5 is 6. Yikes. And here we go with some fractions. 6 divided by 5. Let's keep it clean as a fraction and say 6/5. So how did we set this up? Well, we like working with sequences when it's actually a list of numbers, right? So let's write out a list and put blanks there like I did. Put in the information we do have. They told us the third term, and they told us r is 5. And that's enough to kind of establish the pattern. 30 times 5 is 150. 50 times 5 is 750. And then we got to go backwards. So I'm glad Tira noted that earlier out loud. By dividing 5, we move back in the list. And we found A1, 6/5. So let's plug our parts in and we're done. We could state what the nth term is. A sub n is 6/5 times 5 to the n minus 1. They didn't ask us for like the 20th term or the 100th term, so we're not plugging anything in. We're just leaving it as the formula. Okay. I'm going to move on to the series. So just recall with me that when they ask us about the sums, here we go. When they ask us about a sum, that means we're working with the series formula. And just like with arithmetic, we could add up all of our terms in the sequence up to some given point. They'd have to tell us, though, how far to add up. And that's basically n, is which place in the list we're stopping at to add them all up. Now, we're going to end up with fractions a lot of the time in geometric sequences because, like we've seen so far, you do end up with like dividing by some number or multiplying by a fraction, and then you end up with, on one end or the other, fractions. So we saw it in the last example, and in this sequence here, it starts with a half, and then it's 2, and then it's 8, 32. So find somewhere to determine what your common ratio is. And then you can use that to fill in any gaps and see how it goes together with like stuff like that 1/2. All right, now below, here's the geometric series formula. So just like the other one, it starts with S sub n, so sum or series is the first term, A1, times 1 minus r to the nth power, and then it's all divided by 1 minus r. So again, all we need to know to start using this formula is the first term, and then we need to know what r is to plug it all in. So let's try writing the formula for the sequence above. So let's find r to begin. So from 8 to 32, what are we multiplying by? 32 divided by 8 is 4. So it looks like it's times 4 each time. 32 times 4, that's 128, good. And 2 times 8, or I'm sorry, 2 times 4 is 8. So that must mean 1/2 times 4 gives me 2. Let's check that out real quick. 1/2 times 4. 4 times 1. 4 divided by 2 is 2. Good. So it's working even at the very beginning with that fraction. 1/2 times 4. So the point is we just found r, and we know the first term is 1/2. So if we plug those in, good. Thanks, Savannah. Good eye. So we've got, I'm going to plug in my fraction there. 1/2, 1 minus 4 to the nth power, and then over 1 minus 4. We can simplify this bottom part at least. We can say 1 minus 4, that's 3. Okay. And then we could use this to find the sum of all the numbers in the list up to the nth number, wherever we want to stop it at. And I think to do our first example, finding the sum, I want to do an example without a fraction in it. So is the 3 negative? Oh my God. Thank you. See, check the teacher. Sometimes I'm making mistakes. Thank you, Savannah. Yes, it should be -3. 1 minus 4. Now, you might be thinking, how can they add up to a negative number? We'll actually see the negatives cancel out eventually. So I should have thought about this earlier. I'm sorry. I don't want to do this as our first example because of that half. I'd like to do our first example, finding a series with like no fractions involved. So I'm going to hold on the screen for just a moment if people are still writing anything down. And then we'll try a series example without a fraction in it. And then maybe we will come back to this and check it with that half as well. I just should have seen that earlier and chose otherwise. Okay, so here we go. Let's try using our formula. This will be a good one to practice with. And actually, I'm going to make a little edit. Instead of the sum of the first 10, S10, let's just try it smaller first. Let's try the first 4, S4. Okay, and I want to do it 2 ways. Let's add them up like by hand, normal way, and then we'll try the formula to see how that works and operates and gets us to like a positive number at the end. So the first 4, A1, A2, A3, A4. So to do this by hand, we're just literally adding up the first 4 terms. So let's try that. 3 plus 15 plus 75, and then 375. Okay, I'm going to try that. Check it with me to make sure I'm on the right track here. So 3 plus 15 plus 75 plus 375. Okay, I got 468. Double check me, okay? Let's try the formula now to make sure that it gives us 468. So S4, the sum of the first four, I'm going to do it blank first. We'll plug in our parts. Thank you, Savannah. Plug in your parts. So first term is 3. R is, what's R? We didn't figure that out yet. We have to find R. What am I thinking? What's the common ratio? Help me out. Good. Some people in the chat. Tira, good. Savannah, good. Thank you both. It's 5 times 5. Good, both of you. So 1 minus 5 to the n, and then 1 minus 5 in the bottom. Okay, now I could have already plugged in n. Let's do it now. N is 4 because we're doing the first 4 terms. Here we go. So 5 to the 4th power, and then below we've got 1 minus 5. So that's negative 4 in the denominator. Okay, now let's practice simplifying and let's practice simplifying the exponent and the parentheses and all that. Always do your exponents first if they are in a problem. So 5 to the 4th power, let's figure out what that is. 625. 1 minus 625. Holy cow. Huge, right? Good. Thanks, Anaya. 1 minus that would be negative 624. Am I doing that right? 1 minus 625. Yes, negative 624. I want everyone to practice doing this kind of stuff in your head, mental math, but don't be afraid to use your calculator to check. Okay, so negative 624. And then it's still divided by negative 4. So hopefully you can see now we've got a negative on top, a negative on the bottom. Those are going to cancel and give us a positive number. So let's try doing, there's honestly a couple ways to go about simplifying this stage of the problem. You could do 3 times 624. That's going to get you a larger number, and then you divide by 4. Or we could just divide 624 by 4 and then multiply that to 3. So as long as we don't lose track of any of our pieces, we can do it in either approach. Let's do this. I'm going to hold off on that 3 until the end. So 624 over 4 is 156. Also, negative over negative canceled. I'm not going to cross them out. I'm going to leave them on the screen. Negative over the negative canceled, making it positive. So now 3 times 156, 468. Perfect. Which is what we already knew because we added them up earlier. So again, if it's a low number that we're trying to add, first 4, it might not be bad to just add them up like normal. But if we're asked to find a much farther number in the list, well, you're going to want to use your formula. Okay, now I wanted to kind of bring together Monday and Tuesday and today in one screen where we have all of our formulas that we've learned so far. So let's do that. I didn't make it earlier though. So let's do this. Arithmetic. This is from Monday and Tuesday. And then next to it on the right, let's put our geometric. Arithmetic means it's a common difference. Geometric common ratio. The arithmetic sequence, that's just making the list and finding all the numbers in the list. So that's a sub n is equal to a1, plus d times n minus 1. Pardon me. So that's the formula that we did on Monday. Geometric's sequence list is a sub n is equal to a1 times the ratio to the n minus 1 power. And then the series formulas. So I'm going to add this in below. So arithmetic series now, and that means adding them up, that's the sum for arithmetic, and we want to do it for geometric. Okay, so arithmetic, this is what we did yesterday. Sn, the series or sum, is what? Now I can't remember. Shoot, I didn't write this down. And actually, since I'm on the spot, I can't remember it. I'm going to have to pull it up real quick. Arithmetic series. Does anyone have it written down? They could share it with me from yesterday's notes. Let's double check what I had yesterday.
I thought I might have it, but I actually don't.
Levi, thank you for telling me. It's all good. You know why? I don't have it either. Hang on. Sorry.
Oh, wait. Actually, the formula?
Yeah, formula for Sn from yesterday's notes.
Okay, so I believe it's an equals a1 plus d, and then parentheses n minus 1.
Okay, good. That's the sequence formula. That'll give us any like number in the list for an arithmetic sequence. Do you have the next one that it also has like a d in it and an n minus 1, I think.
Oh, Sn equals n, parentheses, a1 plus an, and then over or underneath that is 2. I think that's it.
That's right, Levi. Thank you. I had a brain fart. I should have wrote it in my notes today, and I can't delete what I wrote. Okay, so the series formula for arithmetic, you said it's n times, what was in the parentheses for that one?
A1 plus an.
A1 plus an. Okay, thank you so much. Saved by the Levi. And who else is in the chat here? Oh, Anaya, you rock. Thank you. Is it, does it have an n on the top of the fraction? Is that?
I don't see one. It's just
Wait a minute. I think you're.
It's supposed to be that is supposed to be outside of the parentheses.
Okay.
And then
Like it is on my screen now. Like, does that look correct?
yes.
Okay, that's what I thought. That does seem correct. Yes, we should have n. That's the number in the place in the list, and then it's times the parentheses, the first term, and then the nth term over 2. That's right. All right, and now to wrap this up, we've got today's series formula, which is the most complicated one. I grant you, because it's mixing together the powers and the ratio and all that stuff. Okay, so this one, is the new one from today. Sum is A1 times 1 minus R to the nth power over 1 minus R. So this is the summary, guys, of everything from this week so far. Arithmetic sequences, that's just finding numbers in the list. And then below, we've got the series, which is the sums. Here and here. So when we're given a sequence, I want us to be able to determine, is this arithmetic? Is this geometric? That means, does it have a common difference going up or down by adding, or is it going up or down by dividing, multiplying? If we can figure that out, then it tells us which set of formulas you'll need. So our first step should always be, what kind of sequence do we have? Is it arithmetic? Is it geometric? Is it adding, subtracting? Is it multiplying, dividing? I'm going to add that into our notes here. So arithmetic, adding or subtracting. And then geometric is multiplying, dividing. Okay, I'm going to leave this up for a moment in case anyone is writing it down or needs to take a picture. For each kind, we've got sequence formulas and we've got series formulas. Oh, I'm sorry. Is it after 12? Okay. Let me take down roll of who's here, and then you guys are good to go. If you have any questions and you'd like to stay, I'll stay on for a moment. Anaya, Anthony, thank you guys. Levi's here. Savannah's here. Victor's here. Robel. Bearcat was here earlier. Beniam. Philmon. Was here, but I'm not sure when you left. Tira, thank you. And Brooke. No Brooke today. And Tatiana, thank you. And Xavier.